I'll just say something quick on that. I think, within the plant network, we're not sure we can stop all the attack vectors, but we can make the applications much more resilient to different types of attacks. And so a lot of our work is, yes, to try to stop it, but also to recover from it and continue with normal operations. And we really like some of the things that are coming out in terms of the time synchronous networks, where you can guarantee a slice of time regardless of what else is going on in the network, because there's certain attack vectors that try to consume the entire network, and that affect your real-time systems. And so those are some of the things that we're exploring to try to bring to the standard control system, so it's a lot more resilient than it has been.
I would say in terms of the point of real-time, real-time's not new for industrial automation, and it certainly isn't new for the internet. I mean, today, if you take a look at ping times or travel times, what we're seeing today versus 5 years ago, I don't think there's a place in the country where we can't get ping times below 36 milliseconds. So I would tell you that from a risk perspective, I think that's going down, because the networks are getting faster, and as we move to IPv6, they're going to get even faster than that. And it's just a matter of time where we're going to be at a point where real time will be will be in sub-second rates. Even today, I mean, when you go over to the booth and take a look at people, there's a bunch of us that are using air cards as wireless for internet for our booths. I mean, I know we're experiencing around 65 millisecond run rates, so not bad.
Kevin, what do you consider real time for mission critical? What is the timeline you're thinking?
Yeah, I was thinking, sub-millisecond, 10 milliseconds. Well, a lot of motion control applications and such, not the raw big data aspect of mission critical, mostly motion control.
So I could show you, but by using hardware accelerators, crypto acceleration, math acceleration in silicon, it really solves the problem. We do all real-time crypto and encrypt the communications and the data, and for all I/O within a system is 1 millisecond, deterministic 1 millisecond. So that's within your timeline, I think. So with the technology today, you don't need to compromise. And that's all I say.
Yes, please.
Keith Campbell, Packaging World. I want to get to the practicality of what we're talking about. I mean, this thing gets a software update at least every day. And you mentioned the need to move from VPN to other things. And we have tens, if not hundreds of thousands of devices yet in the plants that are still running XP. So can we practically have a change management program and a product life cycle that we can live with and do the things that we're saying we know theoretically we can do and practically we can do, but can we live with the consequences?
Yeah.
He's got more plans than me.
So, I mean, it's a great question, and it's a really critical question. And I think, the industrial internet has to bring some of the technologies that you see in the consumer internet and bring them to bear in the industrial world in a way that doesn't compromise the security of your entire network. And, the way the update works on a PC, nobody's pushing that down from the cloud. Your PC is waking up, and it's actually going out and asking to see if there's anything new for it. And if so, then it forms a secure connection and brings something down to it. And, we see that's possible in the industrial world, maybe to update firmware, maybe to update PLC logic, but very carefully based on customer policies, and sometimes based on the fact that there's two people at each ends of the curve, with somebody actually turning a dial for some period of time when that happens. And so we think, the benefit of being able to put updates out and make them available to a fleet of equipment that's out there is going to happen. Whether we lead it or somebody else leads it, it is going to happen. But it has to be done very carefully, and it has to be done according to the policies, just like any other IT infrastructure requires a set of policies before it'll accept updates. And I think the the convergence of IT and OT, this is one of the places that it's absolutely going to happen in the industrial space.
Dale, did you?
Yeah, and I think this ties into the previous question too. And you had that chart where you showed IT and OT separated, and we hear about the differences, but so often we're comparing our DCS, our SCADA, our systems that are running very expensive plants or mission critical systems to desktop management on the corporate network. And of course, those are incredibly different, and they have different user communities, different requirements. When you compare OT to mission critical IT, where you can determine how much it costs for every minute of downtime, on some of these e-commerce apps and things like that, they're actually, the way that you manage those are actually quite similar. And the biggest difference is that OT has accepted a level of insecurity and fragility that would never be accepted in mission critical IT. So when you look at these updates and other things, you're going to see where you have similar requirements in OT that are in mission critical IT, they'll be updated the same way. Where you have lesser requirements for uptime and integrity and availability, you'll see them pushed out and more automated. And I think you're right. It is going to, the best solution is going to be to give the owner-operator some ability to control how this happens.
Do you have a question? Sure.
Pete Anderlo with Kimberly-Clark Corporation. As I think about systems and the different levels of security, I think of the platforms, I think of the users, I think of the data. What are the critical components that people that have to implement systems, what are the tools that we have to think about? You mentioned firewalls. What are those other tools that we're going to have to dig into and be prepared to have in place so that the squishy inside of our control systems are protected?
Sid asked us not to be too selfish, but you asked for it. So.
No, you're just taking advantage of it. Go ahead.
Yeah, no, I planted that question, by the way.
Oh.
Well, there are many products and new technologies today. The technology that Waterfall develops, and one of our flagship technologies is unidirectional security gateways, which allows you to share information or to, in a sense, provide access to data without providing access to your networks. And in most cases, and in most of the use cases that were described here, it provides you, I think, the best solution possible, providing the whole need, providing in full the need for either remote monitoring or having remote access to information while keeping your network actually detached and inaccessible. So this is an example to a technology that is being adopted quite widely and in a growing rate when designing new systems or when putting security in existing systems.
Anybody else?
Yeah, I mean, a couple of comments here. I think, you start with the outcomes that you're after. And so why is the Internet of Things interesting in the first place? And, a lot of people just start with basic reliability programs. I have very big, expensive equipment that has catastrophic impact if it fails in production. Can I start just by predicting when those are going to happen so I can plan the maintenance instead? That's not a two-way problem. That's a one-way data problem. And so, technologies like what Waterfall provides, where you can have the data sort of replicated and separated from the plant network, I mean, those work very well and they're very secure. Technologies like we have that then analyze that and, provide you information back, maybe in the form of a phone call, maybe in the form of some cases that come to you, those are very secure and have limited to really no impact on your control system. I think when you want to start to go to the next level where maybe some process optimization is happening between what's going on in a cloud-based infrastructure and on site, you have to have some additional care. And a lot of our customers start off with just maybe we're monitoring their process loops, and there's 5,000 of them, so they can't keep track of them themselves, but we can tell them which ones are drifting, which ones aren't, and they can manually go and adjust them. I think when it comes to actually doing some process optimization, we prefer still today to put that on site and to integrate it in with the supervisory systems, as opposed to putting that kind of thing in the cloud where it might be a two-way action. And I think that's really the state of the maturity of the industry today is when it comes to control, we like to keep that within the plant's network. When it comes to analyzing the data and providing feedback, we're okay with doing that offsite.
I'd like to add one thing is, and we saw this with the snapshot dongle, was if you're going to deploy something in the field to your customers, make sure you have a secure update capability, because essentially anyone can reflash that device, so there's really no way to ever get the integrity of that device back. Sure, the vendor can upload new code, but so can anyone else. So if you're going to have something that's relatively low cost and deployed in large numbers, having a secure update capability would be pretty high on my list.
And question, Peter, when you say the squishy inside, you mean for your existing sites, your existing legacy installations? Is that what you mean?
All the systems that are insecure by
Yeah. Mm-hmm. I can't really respond to that because I don't have a squishy inside. But it's a problem. Yeah.
You know, Pete, you bring a good point. There are millions of companies out there that are in the same position as you are. You're not the only one. Everyone's got that squishy inside that's dealing with a DCS or dealing with a control system that's not new. And so you got a choice. You can replace the control system, which you probably don't have the budget for, or you can try to put a shell and to control it. I think best practices, one of the things that IoT will do from a promise standpoint is provide you better security layers. That's what it should do. But I think best practices, I mean, everyone should have a firewall, there's no question. If anybody here says that they're not internet connected plant, we know they're lying because they're pushing data out through the internet somehow, some way. I would tell you, put a proxy in. Don't question it, just put one in. If you're really concerned, put a DMZ zone in. It's not a big deal. Most modern proxies can move data. There's not a problem. It'll allow you to give you the isolation. And I think IoT will provide you a solution to connect your older plants. It has to, because we as vendors can't make the assumption that you have to change your entire control system. So we're going to have to work with what you've got. Now, some of these people may disagree with me, but we're going to have to adapt to an old plants. We have no choice.
I guess I would disagree when you say old plants, because you look at the plants that have been deployed, the DCS and SCADA systems deployed in the last year or even being deployed now, they still are insecure by design. So that's one of the things when people, and we heard this from General Tuhill this morning, he talked, well, we have this problem of all these old legacy systems that we're going to have to live with for a year. Let's be honest, we're still putting these systems in.
Right.
And it's going to be, we need to start addressing that.
Absolutely correct. Let me pull the words out, not old plant, but insecure plants.
Just buy my stuff.
Let me ask,
No.
go ahead, Albert.
There's the ICS cert. There's the ICS cert tip 015-022-01. It's a great best practices, fantastic document. I'd recommend it.
Yeah, so I'll add a couple things to the ICS cert. And this really goes at sort of the maturity. I mean, we're a SCADA provider, so we understand what's there. And I think about the maturity that we've had to go through over the last few years with the Prophecy SCADA systems. Well, we started off by being what I would say is very good at reacting when a threat was detected. And, that only gets you so far. I think, you have to get to the next level where you're watching the security changes that come from the vendors like Microsoft and the other content, and within days, you've actually got the next releases that are out there. So if you don't have, sort of that upgrade mindset so that you can constantly take advantage of the new capabilities to prevent threats, you're missing something. Then I think we really progressed to the point where, well, we started attacking ourselves. And, how can we get ahead of the curve and really start to, there's a set of known attack vectors that people use, and we'll try them all on ourselves. And we work with ICS CERT and actually try to address those and put those kind of capabilities into the product. Then you go to the next level, you start to pay experts to come in and attack you and, try to break your stuff and make it as resilient as possible. Is it perfect? No, probably not. I would hate to say that because I'll get another 100 people that are going to try and break it. But, the progression has been pretty significant. And, if you're current on your systems and you've kept them, sort of at the latest levels, they're significantly better than they were 5, 3, even, 10 years ago, certainly. So I would definitely recommend, just like any other software systems, to try to keep them current and try to get the latest updates and make sure that you've got the latest security fixes.
Okay, we're running out of time. I've got one last question then. I'm going to follow up on something Dell said earlier. They're insecure by design, and then you made the follow-up comment that the systems sold last year are still insecure by design. And I'm assuming, and you know better than I, but I'm assuming that companies like GE, and I'm not picking on GE, but the ICS companies are all shipping systems today that probably follow the recommendations of a 62443. I think that, I may be wrong, but I believe that's true from my discussions with them. So, they're putting in firewalls, they're zoning them, they're putting in DMZs, they're doing all that kind of stuff. And you're saying they're still insecure by design, and I think I understand what you mean. So my question is, and I think maybe your question, what more needs to be done to make them secure? Because if he doesn't want to go and buy, the one issue is the fact you have systems, but the other one is, okay, you get somebody in your company say, fine, we're going to replace it. You don't want to replace it with one that's insecure by design because then you'll lose your job. So what more would you do? Yes, that.
Can I
know
answer
you buy
that
yours.
one?
I know it's buy yours, Albert. No, I knew that, and I'm not joking. I'm serious.
No, so am I, yeah. You kind of have to start from scratch because it's a very different paradigm, right? And you need, of course, secure microcontrollers. You need you need FIPS, so your modules have to be anti-tamper. You can't get there from here using plastic. Plastic doesn't work because you can't get the active anti-tamper. You can't seal the modules the way you want to. You have to have a secure OS. So in this case, we're using Integrity from Green Hills, which has the EAL6 plus certification. It goes on and on. You have to have, everything has to be secure. You have to have a key management technology, a key management infrastructure, and you have to secure the entire supply chain. So you secure the chips, you secure the module, you have to secure the ODM or the contract manufacturer. The factory itself has to be secure. And so it's pretty comprehensive, but it can be done.
I think what I would add, and kind of what we've been harping on for a while, is the underlying protocol has to have authentication of the source and content. So, if you look at the Profi standards, they haven't even started adding authentication. ODVA has just started a group to try to add it to Ethernet IP. There's some DMP3 security. A lot of these protocols, you can even upload ladder logic and upload firmware with no authentication. And I think until we get that in place, you will have insecure by design systems. So there's been a lot of progress, and I'd say the HMI engineering workstation server apps, some of those companies are 5 years or more into their security development lifecycle and have new features and much more well-designed code. But until we solve this protocol thing, this is why the industrial Internet of Things is so dangerous, is if we allow remote access from untrusted devices anywhere into these insecure by design systems, we're really opening ourselves up to a much bigger risk than we face today, and the risk today is kind of scary just with spear phishing and normal type attacks.
You going to skip that one, Leo?
Well, I think the problem is actually a lot deeper than that. I actually think from a SCADA perspective, we need to actually change the direction of the data. We have a master-slave relationship today where the master asks for the data. I don't think we should be asking anymore. We should just, the sensors, everything on the network should be publishing it, and you should subscribe to it. And if you do that, then you change the whole paradigm of how the system works, and all of a sudden now you can put in layers of security and certificates to now turn around and create a secured by design industrial system. So change the paradigm around.
Rich, tell them what you're going to do to solve your, or
Well,
just your systems.
You know, I mentioned before the OPC UA protocol, and we see a lot of promises that as becoming a more secure infrastructure for the industrial world. It certainly has been thought through from a security standpoint. It's no longer based on the Microsoft technology, so it'll work across different systems. And, you know, it requires you to have a key-based connection between the two endpoints, and it's an encrypted connection. And, you know, we're going so far as to actually putting that on the controllers themselves so that they can publish their data and make it available to the
A controller being a
supervisor.
PLC?
A
or-
PLC, yeah, right on the PLC. So now you've got a secure protocol on the PLC that's exposing the data to the different systems. And you know, we think that that's a pretty good path right now to go through. But we also are doing a lot of work on the core PLC itself because to some points that were already made, you know, there's passwords that people could get into. The protocols like Profinet are not necessarily secure. Modbus is even worse. I mean, by moving to, you know, the more robust protocols, we think that that's definitely a step in the right direction. And we do like the publish subscribe type environment because you can have some better success, but you still have to worry about the set points because a lot of times the SCADA system is actually, you know, pushing information back down to the control. Either it's a recipe or, you know, changing some values of some of the loops. So it's a combination of things that's going to require. OPC UA, then, we go beyond just the controllers to the HMI. We go to the HMI clients, to the historians, and to everything else. Now you know, through policies, can control the different endpoints and who can connect to who. You could choose, you know, to turn some of that off, but that's not what we would advise. We would advise to make sure that you know which applications are producing data, which applications are consuming data, and that you have good control over that. Oh, one last thing I'll just add. You know, the
Please.
global discovery server, I don't know if that's a concept that people know very much about, but that's a OPC UA component that we've just released. And what that does is it actually manages the certificates. Because if the certificate management is not somewhat transparent, nobody will use it, because certificates are a pain to get right between the two sides of things. The global discovery server is a component of OPC UA that you can use for two purposes. One, to exchange certificates between the two sides and make sure that they're authenticated and based on the policies at the site, but then also to discover the data that's actually out there that you want to subscribe to. So that's a very good concept that's part of the OPC UA specification.
Okay, well, I want to thank the panel. I hope you join me in thanking the panel. Very good discussion.